Hi, this is Dave from notesandvolts.com, and today I'd like to show you my latest creation that I call the stream switch. I've been streaming my builds live on Twitch for a while, and over time my setup has gotten more and more complex. If you've been following my channel for a while, you may remember the Twitch Switch project, which is an OBS remote control box that helps me switch scenes while I'm live. I found this project to be so useful, I decided to make a version 2 that's custom made for my stream setup. And here's the result. The stream switch has light up buttons and dedicated controls for all my cameras and scenes in OBS. So let's take a look at how I made it. To start, I'd like to sincerely thank my sponsors at JLCPCB for providing the circuit boards and helping to make this video possible. JLCPCB has become my go-to circuit board supplier, not only for their high-quality boards and fast shipping times, but also their incredible 10 boards for $2 prototyping deal. You heard correctly. Simply go to JLCPCB.com and order 10 circuit boards up to 10 by 10 centimeters in size for only $2. JLCPCB can also handle large orders, lead-free boards, and custom colors. And if you're into surface mount, they can also make you a custom stencil. So for all your circuit board needs, large and small, make sure you visit JLCPCB.com. I started by prototyping the circuit on a breadboard using a Teensy LC as the processor. I then opened up KiCad and designed a circuit board. Next, I used Fusion 360 to model the enclosure, buttons, and circuit board. This is an important step because it allows you to confirm that everything fits correctly. I then used Inkscape to draw up some front panel graphics. Now that we've finished the design, it's time to bring this project into reality. We'll start by printing the front panel on some matte photo paper using an inkjet printer. I then used a Silhouette Cameo, which is a graphic cutting machine, to cut out the front panel. Once the machine was finished, I carefully removed the graphics from the cutting mat. Next, I used a laminator to laminate the graphics and make them durable. Next, I used some scissors to cut around the edge of the panel, leaving just a bit of lamination to keep it sealed. Using my Fusion 360 model, I was able to print out some accurate drill locations for the top of the panel. I then took the enclosure over to the milling machine and drilled out all the holes. I then clamped the enclosure on its side to mill out a square opening for the USB jack. At this point, I went to my mailbox and found my circuit boards from JLCPCB had arrived. And as always, they turned out great. I could now start soldering the components to the board. The first components were the resistors. I placed them in the board, held them in place with some tape, flipped the board over, soldered them, and then cut the leads short. Now it was time for the TCLC processor. Since this project is using an external USB port, I need to solder 2 wires to the Teensy's D+ and D- pads. I stripped the end of the wires so they can fit into the corresponding holes on the circuit board. To attach the Teensy to the board, I needed to cut some breakaway headers to the correct length. Now I was ready to feed the wires and pins into the board and solder everything in place. And to finish the board, I attached the external USB jack. With the board finished, it was time to start final assembly. I started by cutting out a piece of 3M 468MP adhesive paper. I peeled off one side and stuck it to the back of the panel. I then took some scissors and trimmed off the excess adhesive. Next, I lined up the graphics on the front of the enclosure and created a hinge with a piece of masking tape. I could then pick the panel up, remove the adhesive from the back, and stick it in place. I then took an X-Acto knife and trimmed the panel around the mounting holes. Now comes the real fun part, installing the buttons. The next step was to take some 22 gauge solid core wire and connect all the ground pins on the LEDs and buttons. With the ground wiring done, I could now connect all the signal pins on the buttons and LEDs with 26 gauge stranded wire. And here's the project with all the wires in place. To finish up the wiring, I just needed to connect the wires to the circuit board. And to finish off, I fastened the circuit board down with some screws. All that's left is to reattach the back of the enclosure and stick on some rubber feet. And after a lot of hard work, we are done. I really enjoyed building the stream switch and have found it extremely useful during my live streams. If you want to see it in action, make sure you check out the Notes and Volts Twitch channel. Once again, I'd like to thank JLCPCB for their help with this project. Make sure you visit them at JLCPCB.com. So thanks for watching, and if you enjoy these type of projects, make sure you follow Notes and Volts on YouTube, Facebook, and Twitter. And if you really want to help, I have a Patreon page as well. Okay, I'll see you next time.